Okay. Good evening, everyone. Welcome to the third live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta. I am a PMRF fellow and a PhD scholar from the Department of Design, IIT Guwahati. So the agenda for this class is to help you with your assignments and to clarify your doubts through this live session. So I'll be covering concepts from week 3 lectures, and the deadline for week 3 assignment is tomorrow, which is 17 August. And have you finished your assignments, week 3 assignments? I want this session to be a bit interactive, so please feel free to ask or reply to my questions. You can use the message box also. So have you completed the assignments for week 3?
No, sorry, sir. I had only completed the first assignment because I was busy with the hospital stuff, so I couldn't even attend the classes earlier.
Okay, ठीक है. Okay, tomorrow is the deadline for week 3 assignments, and I will try to cover important concepts that will help you in solving the assignments. Since the nature of the assignments are
Sure,
objectives,
sure.
okay, since the nature of the assignments are objectives, I will not go directly with the objective questions, but I will clarify the important concepts that are part of the assignments. So last week we learned about these topics. So we learned about how product companies compete in the market. Okay, we learned about various types of product design. So what are various types of product design?
Sorry, sir, I don't have any idea. But,
Okay.
sir, only we two are in the session, or there are some any people also?
Let's people join. Since I have started the session, I cannot stop here. So let other people join. They can join later also. Okay, so let me answer these questions. So last in the last class, I talked about various types of product design. Mainly, there are three types of product design. One is original design, okay, where a new technology is being developed. Then there is adaptive design, where a particular technology is used for different applications. For example, if original design is a microchip, the adaptive design can be various application design of microchip. So using microchip, people can come up with like a transistor, radio. People can come up with mobile phones. So all these are application designs, also known as adaptive design. The third is variant design. This is the third type, which is basically a change in specification. Okay, this is like a change in specification. Like we have a washing machine from LG. Then after few years, LG improvised his originally previous design to come up with a new model, and with improved specification. Others also can come, like Samsung also can come up with a new washing machine with better specifications. So these specifications are like they used to change the specification to meet certain user requirements, which previously the previous models generally failed to achieve. Okay. Then we learned about what is stage gate and spiral process of design. As I told you, stage gate is basically a design process which is linear in nature. So we perform various stages of a design process in a linear fashion. So in the very beginning, we have that contextual inquiry. Then we check, okay, the scope for product development. Then we actually develop concepts. Okay, then we do concept engineering. Then we again check, there's a checkpoint again for, for example, feasibility analysis is a checkpoint, can be a checkpoint. Then we go for your implementation. So likewise, stage gate is a linear process where we have stages and there are checking gates at every stages. Similarly, spiral process is used by software companies. The difference is that their product always, launched to the market in an unfinished manner. So there is no requirement of achieving a fine product in the day one. For example, we have version of Microsoft Word, like since 2012. Then we have Microsoft Word 13. So we have versions of software every year. So the companies fix their outcome and fix their, deployment cycle previously, before actually they went into the production phase, product development phase. And each of these cycle is actually one stage gate. Okay, so this is again linear. So we have a, again, a stage gate. But if we look at overall design, it looks like a spiral design, because a product from day one, when we have the idea, took years of refinement, okay, to to have the 100% efficiency. Okay, so that's why the stage gate, various stage gate processes involved here, and it looks like a spiral design process. And what are the key stages of a product design process? Okay. So in the previous class, I gave a, case study. I gave one example of a, you know, a, a design process where a need was realized to come up with a, voice-based TV remote. Okay, so previous remotes versions are, we have all button-based remote controls, which generally used to throw IR signal on the setup box. Then the idea comes that the previous generation remote controls have too many buttons, and the user has to remember a lot of channel numbers. So it is better if we can come up with a solution where you don't have to actually remember the channel names, but speak the channel names. So this is how actually we showed you various stages of product design. Okay, so this was the example I gave you previously, to make you understand the three important stages of product design, which are, understand the opportunity, where basically we envision for a product. Okay, and we go for market opportunity. We do customer need analysis. We actually gather information whether there is a requirement for such a information or such a product from the user and stakeholders. We again do a competitive analysis and various value propositions that are provided by other companies. And then after this process, then we come to a checkpoints, which is like, you know the scoping for product development. That means here we clear this particular checkpoint, that okay, we have enough evidence that this particular need is important and a product can be successful. Then we move to the next particular stage of product design, which is developing a product concept. So in the concept development phase, we initially come up with the conceptual design, which is nothing but the industrial design, having a, uh, you know rough idea about how the product will behave, how the product will look. However, the real analysis begin at the engineering level, where actually we go for concept engineering. We do product architecture development. Okay, this is product architecture development. So development. and then we do functional modeling, and then we realize the product in the next phase. Okay, again here we have a checkpoint. Okay, so there's a gate, and we only define the the evaluation metrics. So for example, a checkpoint can be like feasibility of the design. Okay, there can be others also. There can be multiple, filters which you use to evaluate your concepts, and when you get a green signal, you then move to the next phase, which is implementing a concepts. Basically, in the implementation phase, we go for product detail embodiment engineering. We do all sort of engineering detailing, PCB designing, uh, interfaces design, and we go for user testing to arrive at finally the product. After that, we go for product launch. Okay, so am I clear here? So these are the three stages, and I already taught you these in the previous class. Any doubt till here? Okay, so next is understanding, like one thing, like which do you think, which stage of product design is most important according to you? You can use the chat box to give the answer. Okay, so basically the initial phase, which is the problem identification phase or the opportunity analysis phase, is the most crucial part in any product design process, because the entire project or future of your product depends upon on this initial, opportunity analysis phase. Okay, a product development process can be halted at any stage, like at the development of a concept phase, even at the implementation phase, because of, early errors of identifying the opportunities correctly. Okay, so this is the most important phase in any product design process. Okay. So to understand this opportunity, uh, as a designer, we need to have some sort of clarity on the design tasks. Okay, so do you know what sort of clarity we require? Have you gone through week 3 lectures? Any answer? Okay, so let me give the answer. Basically, for a designer to set the design objectives, to set various goals and design tasks, we need to first arrive at to understand what needs to be developed. Okay, so we have a vision in the understanding, in the opportunity phase, in the opportunity understanding phase. Okay, we have a vision. Okay, which is mostly designer vision. Then to, uh, to confirm the requirements, we do customer need analysis. Okay, we do competitive analysis, market analysis, and at the end we actually, give a green signal at this point. Okay, this particular problem is genuine, and now we can go ahead with a concept generation phase. Okay, but very important thing that one need to understand is like what to develop. Okay, so the key questions comes here are like, are we going to design a original design or a adaptive design, or it can be a variant design. Okay, so these decisions the designers have to make at the very initial phase, and based on that only designer can set their objectives and various tasks related to the concept development phase. Okay, the next thing is technology forecasting. Okay, the very next thing is technology forecasting. So what do you mean by technology forecasting? Have you heard about the term S curve? So what a S curve says is that the technology development occurs like the shape of a letter S. Okay, so this basically defines the technological growth over time. Okay, so the horizontal axis is time, and this is particular technology. Okay, for example, in this particular case, a technology can be, so if you consider this particular product, which is a transition, so the vision is a transition from button based interface to a voice based interface, voice based. So if we see the technological trend, we'll see that the trend of having a user interface with tactile button starts at very early days. Like we have first computers, keyboards. Okay, we have computers, keyboards, which actually use a button based configuration. Like we have keyboards which are button based, tactile button based. Okay, and in the previous generation phones, like the Nokia phones, we used to have keypads. Okay, where user used to press and then interact with the interfaces. However, what happened, like, as so this is how the technology evolved. Like initially there are very less applications of these keyboard interfaces, and then there's suddenly a lot of products used to come. There's a increase demand in this particular kind of interface, and lot of technological growth happen after a certain phase. Okay, then slowly the use of tactile button based interfaces reduces, and now what's happening, like, people is trying to incorporate new design interfaces. Like in smartphones we used to have uh, Google assistants. Okay, and we have Apple Siri for voice based interactions. Okay, so what happens, like, every technology have a similar you know uh, function. Okay, similar, like a S shape. Okay, this is called a sigmoid function. Sigmoid function. Okay, at any particular time we can have both new technology and old technology. For example, this is where you have the voice based interaction technology, and we also have the tactile button. Okay, so this is the point where we have, like, 2022, we have both tactile button interface and we have the voice base. Now a designer needs to look at the scenario that See, if we see here, the voice-based interaction has not reached a maturity yet, and still it's evolving. Okay, and whereas a keypad-based, button-based interface already reached a peak technology level. So the decisions needs to taken carefully to choose particular technology so that the product remain competitive and should be able to capture the market, for a longer duration of time. Okay. Lot of products fails. We products may fail also if we consider new technology, and people are not used to these novel technologies for TV channel interactions. So people are still maybe used to the previous generation keyboard, button based remote control. So a good decisions needs to be taken to consider, should we go ahead with voice based interaction, or we still can go with keypad based interfaces where we'll reduce the number of buttons probably. you know so whether it's going to be a adaptive design or a variant design or a original design, all depends upon how you actually capture the market, what technology you want to address in your design solutions. Okay, so it's very important that we need to have a clarity on the kind of design task we are going to accomplish over the period of the project. So these are two main things, like what to develop and what sort of technology we should be adopting. Okay, any doubt here? Okay, good. Okay, next is another thing is technical questioning. Okay, and mission statement. Okay, so you may see that whenever we have a vision for a new product, so whenever we have a vision for a new product, okay, whether it's a we are looking for an original solution or a adaptive solution or a variant solution, we have some set of questions. Okay, for example, in this particular case, we may have questions like why to press so many buttons. Okay, can't we have a simple interaction? So those are certain questions that comes into designer's mind, where a spark ignites to come for a better solution. Okay, similarly, I already gave you an example in my first lecture that there's a scenario where shampoo sachets, we have these sachets are not available in a mall scenario, in a shopping mall. However, those are available only in small grocery shops. Okay. However, the way they manage these shampoo sachets is cumbersome, and it's not easy to detach this particular unit of shampoo sachets when they are hanged along with the other similar products. However, it is very difficult to manage such kind of sachets in a mall scenario. That's why they have the shampoo bottles, but those are expensive, and also they occupy a lot of space. So the questions that come into the mind is like, can we have something like a device which can store this sort of shampoo sachets, and then it can dispense automatically, and such a dispenser then can be kept in a sophisticated shopping mall scenario. Okay, so those kind of questions comes. Okay, so this process is called technical questioning. Okay, now when we have lot of these technical questions like question 1, question 2, and we slowly answers these we give answers to these questions, what we formulate is basically a mission statement for our project. This is why mission statement formulation is very important, as well as technical questioning is also important. Okay, so basically technical questioning leads to formulation of a mission statement. Okay, so can you tell me why these are important? Okay, these are again part of tasks that needs to do, that a designer needs to perform soon after opportunity understanding. Okay, so do you know why these two activities are important, like technical questioning as well as defining a mission statement, and what are these? So as I already told you that mission statement is basically what you mean by the solution, what the solution is finally going to define. Okay, its specification, what problem it is solving, like what problem it is solving, how it is solving, what is the markets it is going to capture, how unique it is, no uniqueness. So all these aspects are covered in a mission statement, and technical questions along with their answers give answers to these mission statements, and they are important in many aspects. First is to focus your design efforts. Basically you will know at the end of this particular activity that what you are going to design at the end. When are you going to design a device, or you are going to make something like a small tool? Okay, so all these decisions or all these visions get clarity at this stage. Okay, similarly you define based on your decisions, you define your objective, you define your objective, you translate your operational knowledge, marketing knowledge into the product development process. So you translate your organizational skills from various departments to your project. And also you make sure that you have a schedule and a timeline for delivery. So all this possible only when you have a clarity on your design, what you are going to develop, and what will be its features. So all this will be defined by your mission statement. So it define your product. Okay, so let's try to answer this particular case. Okay, okay, so I want you to interact with me. So use your message box to give answers to these questions. Okay, so as I told you, you have a scenario. Okay, where we have where you have shampoo sachets which are not available in a mall scenario, but available in a small kirana shops, like grocery shops. And however they are not easy to manage. So they are not easy to manage, and that's why it is not available in mall scenario. Okay, so here not available, here available but not easy to manage. Okay, so then what happens, like designer come up with certain technical questions. Okay, so here are a few examples how technical questions can be, and these are part of activity that designers do. Okay, so the first question is, what is the problem really about? Can you define the problem? Neil, you can use your mic also.
So first primary problem is to the organization and the need of space.
Okay, so you said problem is need of. See, when you say need, actually you are not.
Space and the organization.
Okay, so see, there's a way how you write. Okay, when you are asked about a problem, you need to define it's from a problem perspective. A need is after a problem. So you have a problem, then we have a need. Okay, so do not try to define a need when we are asked about a problem. This is very important, crucial, so that we understand the difference between a need statement and a problem statement. Okay, so here actually we want to understand what is the problem statement. The problem statement is like, you know, difficult difficulty in storage and management. Management means dispensing, okay, etc. So the nature of the answer also has to be same as the nature of the question you have asked for. So you have asked for a problem, so you just define the problem. So the problems are difficulty in storage as well as difficult to dispense or manage. Okay. Okay, so what are implicit expectations? Do you know this term implicit expectation? What do you mean by implicit? This is a, I think in the assignments, week 3 assignments, in the several places you were asked to choose certain examples where they have asked you to choose the implicit expectation. Okay, so do you know what is implicit ex- expectation?
Some expectation it need to be satisfied.
So basically implicit expectation means it is basically a true, need. You are not defining a solution. Okay, not a solution. Okay, so we have a tendency, like whenever we ask people like, okay, this is a problem, what do you think is the need? People say, okay, I need a two-wheeler. Okay, if you ask someone like, okay, it is difficult to go from this place to that place, so what do you think is the requirement? So the person may say, okay, the requirement is a cycle. Okay, that means this is solution biased statement. Okay, so a implicit expectation is basically a true need. Like when you are defining a need from a higher perspective, then you will see that we do not need a cycle, but we need some sort of locomotion. Or you can go even higher, like we need to way to move. Okay. Okay, so this is how actually we formulate our need statements. For example, I can again give you examples like, uh, for example, for this particular device, if I ask you what is the implicit expectation, so one may directly say, okay, we need a sachet dispenser. No need for a sachet dispenser, or need for a machine. So those are not implicit expectations, those are like solution biased. So you need to come up with a better expectation. So here expectation again similar, like a way to manage and store shampoo sachets, you know, to dispense, okay, with ease. So this kind of statement you formulate when we are asked to define the implicit expectations. Okay, So next is what characteristics the product must have. So all these are actually questions that a designer asks himself or to the team and try to get an answer to to have a product or solution which is competitive to the rest of the market products. So this phase actually happens soon after your you know opportunity analysis phase. So what characteristic the product must have? So you may think like, okay, uh, product should store at least you know 100 sachets. Okay, you may also say like, okay, the product should accommodate products from sachets from different companies. So maybe like accommodate sachets from different companies, like you have Dove shampoos, we have Sunsilk, so like that. Okay, so those can be like the characteristics that you decide that the product must have. Similarly, a technical question can be like, what the product must not have. Can you define one?
It cannot be bulky, or we can say
Okay, yeah.
difficult to use.
Okay, so cannot be bulky. It's a good characteristics. So that you initially said like it has to be easy to store, so cannot be bulky. Okay. So what are the technical and technological conflict inherent in the design process? So now you need to think about, have you defined anything that are actually contradictory? Can you think about anything? Contradictory requirements?
I'm not sure about this, but over here we are defining that we need to we need to store more numbers of sachets, and we are saying that it not have to be bulky, because if we are going to store more pouches, then it is going to be heavy. But it should be easy to use. I can
Okay.
say the customer can use it easily, because if you
Okay.
need a dog, then you can select a dog and you can get the pouches of dog. Or if you select a sunset, then you can get a sunset. It won't be that much complicated for the customer perspective.
Okay, so you are right. Actually, here we have two contradictory needs. Like one is storing more sachets versus should not be, like cannot be bulky. So now we need to compromise. Like we need to decide and come up with certain quantitative value. Like what should be the size of your device versus how many sachets. How many sachets. So ultimately, you need to come up with specification, quantitative measures to define your design. Okay, so that's the reason why this technical questioning is very important to arrive at your specifications in terms, as a mission statement. The another question can be market opportunity. So in the market, you need to ask like, are there similar products, and if there exist, can we have you know some different value propositions, or if there is no product, what sort of market segment we can capture. Okay, can we sell at a mall, or can we sell at a retail store, or can we actually use the similar design for other purpose. So all these questions, when you ask, you will get certain answers which actually clarify your design requirement. It makes the design requirements more visible and help you streamline the rest of your product development process. Okay, so the nature of a product statement, mission statement is like this. So this is like a table. Okay, so where at one line you are now trying to define your product. Can you define?
Yes, we can. Now we can define that our product should store certain numbers of pouches, which
No,
will
no,
benefit
not in
two
that
more
way.
companies.
Okay, see, not now. A product should means it is a desire, it is a need. Now you are saying a product description like a marketing guy. You are saying like a dispenser, or you can say a a storage unit. You know. So now you are trying to define the form and the function of the product using a description. Okay, so basically in a product description, when you are trying to define using uh, sorry, not this is not online, this is one line. Okay, so you are trying to define your product in a short passage or a single line, so you try to incorporate what the product. Okay, basically is it a dispenser, is it a storage unit or something else, what it functions. Okay, function or form, and what problem it solves. So all this information, if you can provide using a single sentence or small paragraph, then that is your product descriptions. So if you see Amazon, whenever there is a product, the seller, there is a section where there is a product description. Okay, so that is basically the description of that particular product, what is it's about and how it functions and what benefits that particular product gives. So basically what is this product about, what how it functions and what benefit its particular gives. So all this information should be incorporated in the product descriptions. Okay, next is business and humanitarian goals. So this is basically internal purpose for your project management. So as a company you decide on your business goals. Okay, also you decide on the humanitarian goals or the social service you are going to fulfill using this particular design. Okay, here it's like you know affordable, make affordable way to provide shampoo sachets, really affordable way to provide shampoo sachets in a mall scenario. So those can be like some social benefits. Again, like for retailers it can be easy to manage. So that particular guy here, the retailer, he may get benefited. So those comes under humanitarian goals. The primary market can be your mall. You can think about retail, small retail store. Okay, like that. Secondary market, you may think about like this product can be used for other purpose also. Probably the same device or technology can be used for not only shampoo sachets. Probably it will be used for your ketchup, your ketchup market. So where you can dispense again ketchup and other sachets also. Like there are a lot of sachets available these days. What are assumptions? Can you tell me what are the assumptions in this particular problem?
So we are going to assume that this product can hold 100 pouches for each company. So we can utilize 4 of the company at that time.
Okay, that is basically a technical problem. Okay, that is actually you can solve. The assumption actually here comes from the overall, opportunity perspective, from the perspective of overall opportunity. So assumption is like we are expecting that the companies who produce sachet, they will keep on producing sachets. If they stop, then your product fail. So your product fail because the shampoo sachets are no longer available. So your product is a dependent product of another product, which are sachets, right? So if they stop their production, your product also stops here. That's the reason why you have assumed that to have this product successful, you're assuming that your the shampoo sachets should not go out of the market. Okay, so similarly there can be other assumptions also. Okay, we are assuming that retailers are will be happy to buy this particular product, provided that we they have the sufficient power source to supply this particular device. Okay, next is stakeholders. So who are the people involved in this entire product chain? So
It means the person who are going to use or the person who are going to design.
everyone, actually stakeholder means everyone. From it is like a complete, you have a product from initial design phase, then you have a company, right, who is selling this particular product, your device basically, and then in the marketplace it is used by some other entities, like this is like a retailer, this is like a mall. There's a company which is actually supplying these essays. So tomorrow that particular company actually can buy out your device, or they can actually directly in contact with your companies, and you can have actually a B2B business, business to business. Okay, so these all are stakeholders in your design. So you need to consider all their benefits and all their issues they may face during the design process. Then next is opportunity for creative design. So this is like, if there are a lot of competitive products, okay, do you realize certain some unique selling point that you are actually proposing in your device to remain competitive? So this is like same thing, like you are coming up with a creative design solution so that you stay competitive in the marketplace. Scope limitations. Scope limitation, like what is the technical limitation, or what is the design limitation that actually exist in your design. So you can say like, okay, it cannot store more than 50 sachets. Okay, it can only dispense one sachet at a time, like one by one sachet. Okay, or it can run for 4 hours continuously. So those are scope limitations. So you only define these, actually these are not the final product that exists, but this is what you define, how your product should what the feature of your product, and how it will be at the end of your product development cycle. So this is what you define. So any doubt?
No, sir.
Okay. Okay, so have you heard about these terms, reverse engineering or redesign? What is redesign? So we have heard about design, right? Design, product design, and then we talked about three types of design: original design, adaptive design, then variant design. So what is redesign, and why we redesign?
After launching some product in the company, or we can say after some time, the need of the requirement will be changed. At that time, we have to redesign our product so that it can satisfy the arising queries or arising needs.
Okay. So redesign, we call it redesign when a existing product design fall short in providing certain requirements. So those can be customer requirements, technical requirements. You can have you desire that you will design a device which will dispense sachets, like it 5 sachets in a minute, but you end up dispensing only one sachet in a minute. That means you have done something wrong in your engineering. So you need to redesign. Okay, redesign your engineering, the circuitry or the mechanism. Okay, so that is why it's called redesign of now engineering unit. Okay, the problems comes from the engineering design side. Similarly, the problem can be at the specification, like user, like customer requirements. Okay, so whenever you try to sell your product, people reject straight away your product because they do not like certain features. So then you need to go for redesigning. So redesigning is different than variant design. So variant design or incremental design is something like when you have a product, then you have a next version of this product because new needs comes. Okay, you have a need, you have certain need, earlier. Then as time evolves, new need arise. Okay, this is not redesign. This is basically a variant design. Okay, variant design means you have changed the specifications. Changing specifications to better fit the new requirements, and user requirements always evolve. Okay, in the first class I gave an example, right? So initially for shaving we used to have those blades, the barber shop blades. Then we come up with a razor, razors. Then we have this motorized shaver. Okay, so every time the need evolve, need evolve over time. That does not mean that these are redesigns. Okay, these are actually, this can be actually variant design or can be adaptive design. So a redesign actually can be any of the three types of design. For example, if you do not like a particular laptop, in a company come up with a laptop, and they realize that laptop will not serve or solve their particular purpose, they may actually go for a completely new system architecture and come up with a new processor. So this is original design. Okay, now they have a new technology with a new processor. So this is the original design. A company can come up with a adaptive design. For example, they thought that laptop will not serve, but a desktop may serve their purpose. So now they have a desktop. Okay, so that is adaptive design. Or they can come up with a redesigned solution which can be another laptop with a better specification. So all the three types of design may occur in a redesign process. So main thing we need to remember is that whenever a existing product fail to meet certain requirements, we redesign. Okay, that's what is called redesign. So what is reverse engineering?
There is a product,
Okay.
and if it fails to mitigate any of the specification or any of the need, then we are going to recheck our design and our process uh, in a reverse order so that we can identify what is the problem and how we can solve it. So this is called redesign. reverse engineering.
Okay, so that is one. Okay, that means to solve uh, previous reported issues. Am I correct? So this is what you mean.
Yes, sir.
Okay,
Yes, yes, sir.
so yes, this is one way. There are other no way of reverse engineering also, and other motivations also. One is like, the other can be like to understand complex technology. For example, China, like they do a lot of reverse engineering on their aircrafts from other. They still, you may heard that they still product blueprints, and they reverse engineer and then come up with a better solutions. This is what they did for their J-20 stealth fighter. So basically, they stole the blueprints from F-22 Raptor. Have you heard about this?
Yes, sir.
Okay, F-22 Raptor is US stealth fighter, and China actually stole there are evidences that they stole their blueprints, and then they developed the J-20. However, in the new design, they have come up with a, what is that called, in the front, two additional, I forgot the exact name, fins actually, which actually provide different aerodynamics than what actually F-22 is meant for. So F-22 doesn't have these front fins, which actually J-20 has. However, if you look at the design, because at that time when only three countries have stealth fighters, we had Russia, who tried to make the Su-57, which have a unique different design. Then we have US with F-22 Raptor. Then China comes, and it looks like lot of features resembles with F-22. That's why people started arguing and giving reasoning that F-22 actually, or the J-20 actually is a derivation from F-22 Raptors. Okay. Also, this is not legal way of doing reverse engineering. This is not illegal also. I mean, if there are IP involved, and IP means intellectual property involved, and you are trying to reverse engineering some of such product which have IP involved, and then you try to commercialize such product, then this is not legal. Otherwise, reverse engineering is a method where actually we dissect basically, to understand complex technology. We dissect a product and try to understand how it functions. Understand how it functions. So from the design sense, if there is no IP involved, then this is what is legal for reverse engineering. Okay. The third category can be to understand competitive products value proposition. So if you are a new, for example, washing machine company, and then you buy products from LG, Samsung, and then try using them and understand how they function, then you try to take some of their good things and incorporate in your device. This is to understand the competitive product value proposition. This is again legal if there is no IP involved with it. Okay. And sometimes to create better product. Okay. Then what exist. So for example, in lot of time people complain about particular company or particular design. For example, Apple phone 6, they have iPhone 6, I think iPhone 6, they have complained about bending whenever they used to keep it inside their phone, inside their pants. Okay. So several companies actually bought Apple phones and tried to analyze why this happened, actually why the phone bent whenever it is kept in tight pants. Okay, they then realized that okay, it is because of the material, since it is the first time they use aluminum, not first time, but it was a aluminum body and with lot of cuts, and the thickness was also very less. That's the reason why the phone got bent. So to analyze the shortfalls of past product and to make a better product, people do reverse engineering. Okay. So am I clear? So we have four motivation. One is, as you said, to solve previous reported issues, which is your own product. If you face certain technical issues, you do reverse engineering. You go back and check where you did wrong and you correct those. This is one. Second thing is like to understand complex technology. For example, if you want to make an hair dryer, okay, and you are not from a technical background, you may actually reverse engineer a hair dryer. So you open a hair dryer and see, okay, inside there's a battery, there is a coil, there's a blower. Okay, then you come to know that okay, this particular design have these particular components and features, and that's how it is working. So now I can make my own design. So there is nothing wrong here as long as there is no IP involved. Okay, no intellectual property involved. The second is like to understand the competitive products value propositions. You, whenever you are new in the market or you want to bring a new product to the market, then you look for other product features. And Apple and Samsung do this actually. Whenever Apple want to make a new phone, they actually look for previous Samsung phones and then make better make their phone better, and better than Samsung phone, and it's do that for its one. Okay, so Samsung do the same with Apple phones, and Apple also do the same with Samsung phone. Okay. The fourth aspect is like to create better product than the original, or if the product have certain shortfalls, we do reverse engineering and to understand the issues and then come up with a better solutions. Okay, this is not same as this one. This is if you are the same company and it's your product, and this is when someone else is dissecting someone else product and then try to address those issues. Okay, am I clear?
Yes, sir.
Okay. So basically, reverse engineering process comprised of sorry, I just want to mention that reverse engineering itself have these different four motivations. Okay, and redesign again have different motivation. Okay, so redesign means when there's a problem with the existing product which falls short. Okay, then similar to that redesign, we have something here also in reverse engineering. Then when we do reverse engineering, when there is a problem or issue, okay, with your product, okay, that's why you redesign. Okay, redesign or reverse engineering. So in this particular context, both redesign and reverse engineering make the same sense. However, reverse engineering is a bit broad. It has more implications. So next is reverse engineering and redesign process. So whenever we do this together, we do generally this whenever we face certain issue with a previous product, or we do not have a clue about certain technology, then only we do reverse engineering as well as redesigning. For example, the example I gave before, if you want to make a hair dryer and you are not from a technical background, you do not have the technical knowledge how uh, what are the components that goes inside a hair dryer, and then you actually dissect and look for various components, okay, and various engineering requirements, and that needs to be part of the hair dryer. So you understand those and then actually you go for redesign. So that is one case. So this is the overall reverse engineering and redesign process, where actually we we envision certain hypotheses for our product. For example, we say like, for reverse engineering, we always have a product. Okay, we always have a idea of what we are going to make. Okay, so we have already investigated something. Okay, and we hypothesize that this particular solution will solve that particular problem. Okay, for example, imagine we do not know the technology inside a voice operated remote control. Okay, and we also do not know how the button based remotes works. Okay, so here we have a IR based technology, and here we have a speech recognitions. Now we are saying that we want to make a solution which is a voice based remote control. So that means the solution needs to have a voice recognition modality as well as a IR signal modality. So whenever the person say particular channel name, the voice recognition should understand like what the channel name, and accordingly the IR sensor should trigger the signals, the IR signals, to the setup box or a TV. So if you are not from technical background, or if you are not having the knowledge, you need to actually dissect a product, various products, like products having voice recognition modality, products having IR signal modality, and then try to understand the architecture, different architecture, and then you try to combine those and come up with your solutions. So this is a reverse engineering way of designing a product. So basically what I said is like, first you come up with a hypothesis, like, okay, you have an envision, like, okay, we will come with a voice operated remote control. Then you do product dissections and reverse engineering to understand the product architecture, okay, the functional components, okay, various features. Okay, so all this you understand through product dissection. Okay, and then if there's a requirement for redesign of modeling or analysis, then you go for it, or you can directly adopt the understanding and you gather from product dissection to your design analysis. Sorry, it should be here. Okay, to your final designs. Okay, so this way we actually go for reverse engineering and redesign process. Okay, as an outcome we can have a either a original redesign or a adaptive redesign or a variant redesign. Okay, so the modeling and analysis phase is optional only when it is required for further modeling or analysis of the design. For example, here if we understood that voice recognition modality have these particular architecture and features and components, and IR modality have these components, you need to check whether just a combination of these two technology will straight away give you the solutions, or you need to do further analysis or modeling. Okay. Okay, so that's what this particular diagram represents. Sometimes you need to do additional design modeling and analysis to come up with solution, or sometimes directly, based on your understanding from product dissection, you can go for designing your product. Am I clear?
Yes, sir.
Okay. Okay, so last is a case study of reverse engineering and redesign process. I have a company. I had a company. It's called Chiker Private Limited, and we, along with my co-founder, actually designed a medical product. And as a part of the overall design process, we uh, for some of the phases of the product design, we use this particular reverse engineering and redesign process. So what we did is like we considered one of the competitive product at that time, and we try to understand, like, what actually goes inside this particular device. So this particular device was a negative pressure wound therapy. Okay. Negative pressure wound therapy device. Okay. What it does is like it accelerate wound healing. So there are certain wounds which uh, have halted or altered, biomechanism, because of which wounds does not get healed properly and does not heal in time. Okay, there can be infections, or there can be other issues. There can be diabetes also, which leads to such condition. So in for healing those kind of wound, we generally provide negative pressure wound therapy. Now, as a technology, this is already patented in 19 I think 1998 or 1999, and the patent expired in 2018. Okay. So in terms of IP, we did not have any issue in reverse engineering. So there is no legal issue in reverse engineering the product. And this particular product was a local Indian product which actually adopted the particular patent technology to develop their own product. However, we were given a complaint by the clinician that there are a lot of issues with this particular device, and there are issues of leakage, there are issues of poor design, mechanical design, pure mechanical design. They use very poor quality plastics, and lot of their attachment, like, attachments are very fragile, and they doesn't look like a manufactured product. It looks like a handmade product in several features. Okay. So what the reason or motivation behind reverse engineering was to understand the issues the present product have, and to improvise and to come up with a better product. So this is the motivation to come up with a better product, a better product. Okay. So what we understood by dissecting this particular design is that, there are certain critical technology they had for air pressure control. Okay, which are generally not needed if we actually do certain software level control system. Okay, but they have done this mechanically, because controlling air pressure when it is at high pressure, it is very difficult. That's the reason why they come up with a microfluidic device, and where air actually passes very slowly, so that they can easily control, you know so there is not much fluctuation on the control pressure level. Okay. We also try to understand their connections, and try to understand the architecture they are following. Okay. and also we try to understand the defects the product existing solutions have. They have a lot of issues, like they have openings at the bottom where actually there are chances of additional infection and bacterial growth, because these sort of wounds can have contaminations, and these openings at the bottom actually can cause further contamination to the environment. So we can have chances of environmental contamination. And there are very, some of the parts are very not engineered parts. They are like handmade parts which were added later, and because of that these particular portions are very flimsy, and always there are issues of leakage. And also the quality of pumps and the various circuitry they used to have is very poor, and often the clinician actually has to call the service providers to repair their devices. So based on these understandings, we actually come up with a better architecture and also improved technology, where we are not only providing a negative pressure wound therapy, but also we are providing another therapy parallelly. Okay, so based on understanding of their circuitry, we did certain modification to our circuitry. These are airflow circuitry to achieve certain advantages which they are trying to achieve using this particular microfluidic device. Okay, so we achieve those only by changing the architecture of the fluid circuitry. And also we incorporate new modality for wound therapy, which is oxygenation. And this overall improve the product functionality, and we create a new value proposition. We come up with better interfaces. Okay, so earlier previously it was like a button, four button interfaces does not define like which button is made for what. And they used to have a small navigational window which is like a 8-bit window. Okay, and it is very hard to navigate. There is no clear instructions, and we make it more like a mobile phone interface, which have better legibility of information and better information architecture. And this is the better hardware. We have improved circuitry with lot of safety protection for electrical fluctuation. We have what is a constant voltage and current circuitry. So all these engineering development or changes we did to arrive at your final design. Okay, so I hope how reverse engineering and redesign process can be useful in improvising or creating new product. Any doubt?
No, sir.
Okay, so thank you. Like this is the end of today's sessions. I have shared the previous sessions video in YouTube. Let me share the link here. Okay, so I have shared the YouTube playlist link in the message box. Please go through the previous lectures to clarify your doubts. And tomorrow is the deadline for week 3 assignments, and please finish your assignments on time. So next class will be again the next with next Tuesday same time. So I'll cover concepts from week 4. Please go through week 4 lectures by Professor Asokan, and then I will clarify your doubts related to your assignments. Okay, thank you. Bye.